Okay, so now we're going to do volume by shells, and we're going to rotate it about something other than the X or Y axis. So this first one, I'm going to rotate it around. I'll just kind of remind you, this is what we know. If we rotate this area here around the x-axis, I draw the rectangle parallel to the axis of rotation, so it makes this shell, and from here to here is the radius, and that's what we call the distance of y, right? From here to here is a y value, so that's what this y is, that's the radius. The g of y is the height, that would be the x equal in terms of y, the function, the thickness, and so that's 2 pi radius height times the thickness. Okay, so that's what we've been doing. So now we're going to rotate around a different horizontal axis, and so we're going to have to change the radius. This will still be the height, right? That will still be the height of the shell. So r of y will be the radius. So let's look at what we've got here with this picture. So here I have y equal root x, y equal 1, and x equals 0. So here's the area bounded, and I'm revolving it about y equal 2. So let's put y equal 2 up here. Oops, there it finally turned blue. Okay, y equal 2, there's the center, right? Center is key. Okay, so let me get another color here. So I'm going to draw trying to get a different color, rectangle parallel. I'm going to spin it around so I can see the shape, because I really want to be able to identify what the radius is, right? Okay, so let me go back to black. Okay, so my volume is 2 pi, radius, height, thickness of my rectangle, which is dy. Okay, so let's do the hardest part first. So let's do the radius. So I want to put the radius in here. So the radius is this distance, right, from here to here. There is my radius. Okay, so remember, from here to here was a y value, and so now what do I want? I want for all of this distance. So I want to go up to the distance of 2 and then take away y. So go up to the distance of 2, go up to this height of 2, and take away y, and that will leave me with this distance, which is the radius. And then I want the height. So the height of my rectangle is going to be from here to here. So I want to have x equal this function. Oh, it's not in terms of x right now, is it? So I need to solve for x. And so I get the height of the function is y squared. Now remember, because it's dy integration, these have to be on the y-axis. So I'm starting here at 0, and it looks like I'm going to end here at 1. So I'm going to start building the rectangles at 0 and end building them at 1. All right, so let's do y equal x cubed. Here's x cubed. Y equals 0, you know, is this, x equal 1, and now I'm going to revolve it about y equal 2. So again up here, so that this is 1, this will be 1, right? So 2 will be up here. Okay, so this is the center line again, right? So let's draw my rectangle parallel to the axis of rotation, right? So it's parallel to this, spin it around. Don't need to see the three-dimensional shape. I just need to see what this one rectangle does. Yes? Okay, so now I'm ready to do volume is 2 pi, radius, height, and I can see the thickness is dy. Okay, so again, the radius is going to be from here to here. So I want to say go all the way up to 2, go all the way up to this distance of 2, and take away this distance, which is y. So 2 minus y again for the radius. The height of the rectangle will be here to here. So remember, I measure from here. So I want to say go out to here and subtract this off. So go out to here. This is x equal 1. So I'm going to go out to 1, and I'm going to subtract off the function, but I can't put x cubed in there. So I have to solve this for x, and I get y to the 1/3. So then I'm going to find the limits of integration from 0 to 1 on the y-axis again. All right, so let's see what I've got here. 1 over x, y equal x. and then y equal 2. Okay, so this must be the point 1, because I know they must intersect at 1, 1, and there's 1 also. Got to have context. And then this is y equal 2. So I see the area I've got bounded, and I want to revolve it around y equal 3. Oops, tried to change the color here. Let's try it again. Y equal 3. Okay, so y equal 3 is here. This is center. Y equal 3. Okay, so I'm going to take my rectangle parallel to the axis of rotation and spin it around. There it is, right? Okay, so this has got everything changing on us. This is a good challenging problem. So here I'm going to have 2 pi, radius, height, thickness of the rectangle, which is dy. Okay, so let's tackle the radius. So the radius is this distance here. From here to here is the radius. I know from here up to here is y, right? So to get this distance, I want to say go up to 3 and take away y. Go up to that center line and take away y. That gives me this radius here. And then the height of the rectangle is going to be this distance right here. So since everything gets measured from the x-axis, I want to say go out to the line. So what's the line? That's x equal y. And then I'm going to subtract off, take this away, which is this function here. So again, I need to solve this for x equals, so I get 1 over y. And where am I going to build rectangles from and to? I'm going to start building the rectangles at y equal 1. Remember, these have to be y limits. And I'm going to end building them at y equal 2.